So Janta, welcome once again to my channel Puzzle Funding, and today we are here with another SUDOKU variant puzzle. This is known as Tetrafolium or named as Tetrafolium, and this one is by author Ul-Rhymm. I think we have solved a couple of puzzles by Ul-Rhymm, so we are really good, and I hope this puzzle is also going to be very good. Anyway, I mean it is very good. It is 97% rating on German logic and 3-star difficulty. So give it a try, and of course if you are watching this video, that means let me read the rules first. So the rules are standard Sudoku rules apply. That means in each row, each column, and in each 3x3 box, the digits 1 to 9 occurs only once without any repetition. Killer cages. So these killer cages, the cages which are enclosed within the dash lines, they are called as killer cages. And what does this mean is that the digits that we are going to, in cages, digits do not repeat and sum to the values in the top left corner, right? So in these cages, the digits will not repeat, and whatever digits we are going to put here, the sum must be whatever is in the top left corner. It must be that sum. So in this case, we should put the digits which must be sum to 6. This case, we must put digits which must sum to 9. That way, modular lines, each set of 3 consecutive digits along a line contains one digit from 147, one from 258, and one from 369. So these are modular lines, or what they are saying is that we should divide all these 1 to 9 digits into 3 groups. One group containing 147, one group containing 258, and one group containing 369, right? And now what will happen into this line? Let's take example of this line, that if one of the digit from any one of this group, so let's say that is from 258, which is 5, then these two, any 3, if this is one from 15, then let's say this is from 69, then this must be from 147, right? You cannot have any of 258 here or any of 369 here, because then this 3 cannot have 3 digits from the these 3 groups. So any 3 continuous digits must have 3 different digits from these 3 different groups. So that basically it means that. So standard Sudoku rules, modular lines, killer cages, and standard Sudoku rules. So with that, I am going to start, and if you are watching this video, that means I am able to do it, and if I can, then I have the anybody can. So please give it a try. It's a nice puzzle. Right. So so it's very much kind of similar, right? If you see, I think it's 90-degree rotated. See this arrow. If you rotate that way, then it will 90-degree, counterclockwise, I guess. Yeah, then it will become like that. And then if you again rotate one more time, it will be like that. So this is like 90-degree counterclockwise, 90-degree symmetrical. This puzzle is, and these two lines are also there. So what is differentiating? Even these cages, right? If you look at the shape of the cages, they are also same. See 1, 1, 1, 1, 90 degrees. So this is So this is like 90-degree symmetrical puzzle, and even now these cages are also same. So So basically, what the symmetry means is that whatever we do in one part of the grid, we can repeat it into the other part of the grid. So something which we can do here, we can repeat here, as well as we can repeat here, as well as we can repeat here. Maybe, I mean, that is possibility. Now to start, right? So 5 cages in so 5, the digit 5, in terms of 2-digit sum, there is only one possibility. Either it is 1 4 or it is 2 3. Similarly, 6, there is only one possibility. It is either 1 5 or it is 2 4. So both these are 6 cages, right? So these must contain 1 2 4. And now look, we got this 1 2 4 5. What you call this quadruple we got, right? That means the digits 1 2 4 5 will occur only here, and so in this box, the digits 1 2 4 5 cannot occur in any other side. So 1 2 4 5 cannot occur here. So these digits must be from 3 6 7 8 9. So I mean, you can pencil mark that, but I don't want to pencil mark that. 9 could be multiple in these 3 cells, but at least 2 of those must be low, because the simple thing to see that even if only one is low, then the other 2 digits, right? I mean, by low I mean 1 2 3, right? 1 2 3 are the low digits. that I am talking about here. So if only one is low, the other two digits is 4, 5, which is 9, and then even if you add 1 here, that will go to 10. So we can't have that. That means in 9 cage here with 3 digits, at least 2 must be low. 9 here in 2 digit cell has 4 options. It's 1, 8, 2, 7, 3, 6 and 4, 5. But 9 could not occur in 9 cell, obviously. Here 7 and 8 cannot occur, right? Because even if 7 is here, the rate must be 1, 1, which is not possible because both the ones will be looking at each other. So 9 cage do not have 7, 8, 9. I mean, at least these 3 9 cage do not have 7, 8, 9, and this 9 cage do not have 9. 10 is again 4 ways, right? In 2 cells. It is 1, 9, 2, 8, 3, 7 or 4, 6. Right, so I think that will take us to this modular lines, right? So yeah, so why this is called as modular lines? So we have to dive back into a little bit of mathematics. It may take some time, so maybe you go forward if you know what is modular mathematics is. But for those who don't know, let me explain a little bit about modular mathematics, right? So basically, modular mathematics is based on the mod operation, right? And what is mod operation? It's the remainder when you divide one number by the other. Whatever the remainder you get, that is the mod operation. So basically, what we say is that 5 mod 3 is going to be 2, because when you divide 5 by 3, you get the digit 2. So the mod operation take two operands, right? It is called an operand for two numbers, something like 5 and 3. So 5 mod 3 is going to be 2. Right? Similarly, then 4 mod 3 is going to be 1, because when you divide 4 by 3, you get the remainder 1. And this modular operation, right? Then it has some good properties, multiple properties, kind of surprise properties if you don't know about the modular operation. So the one property is that the addition, right, of two modular. So yeah, all this will true only if the modular is same. I mean, if you are dividing by the same digit. So so one property is that if you are taking two numbers, taking modular of them and adding them, that will be same as taking the addition of those two numbers and taking the modular. So what do I mean by that? So let's take this example. So 5 modular 3 is 2, 4 modular 3 is 1. Now if you divide these two numbers, right, 5 plus 4, that will be 9. So what I am saying is that whatever is the modular of the sum of these two numbers and take modular of that will be same as the taking sum of these two numbers and taking modular of that. So if you take the sum of these two, which is 3 modular 3 is 0, right? Because when you divide 3 by 3, it will be 0. And what is the sum of this, which is 9? And 9 modular 3 is 0. That is also 0. So the modular operation, right? It's kind of expand over addition. And same thing with the division also. So if you take divide take the subtract one number from the other, right? 2 minus 1. So that will be 1, right? And 1 modulo 3 is 1, because when you divide 1 by 3, you get 1. And now do the same thing here. So 5 minus 4 is 1, right? So you will again get 1. So even subtraction operation is kind of you can do expansion on that. Similar things happen with the multiplication also, but I think for this puzzle, addition and subtraction is enough. So if you see, right, this modular lines is basically what is happening. This is all modular 3 lines, because the groups are created like 147. So 147 group is simply means when you divide any number from 1 to 9 by 3, when you get the modular 1, it is that group. So if you divide 147 by 3, you will only get modular 1. Similarly, 258 is actually modular 2 group, and 369 is, we call it that modulo 3 or modulo 0, or maybe both. We can call it as maybe both. I mean, sometimes I may call it as modulo 3, sometimes I may call it as modular 0. So that is what this line is. So one of the digit is from one modular group, the other digit is from other modular group, the third digit is from the other modular. So that's why these are called as the modular line, because these are fully based on the mod operation. Uh, Also, these lines, right, like any other uh, entropy line or German whisper line, has this property that one group is going to repeat in the regular interval. So basically, what do we mean that let's say this is from one of the one modular group, this is from another modular group, and this is from the third modular group, right? Because this modular group cannot repeat here because these all three must be from the different modular group. So I'm just representing this by color. So let's say this gray is some modular group, blue is some other modular group, and yellow is third modular group. So what is this modular group? Now these three must also be from the three different modular groups. So that means this has to be now whatever is this modular group. So this modular group is repeating here. So this kind of repeating properties is there on both these. Also the the reverse application of is that whatever modularity is this, right? You cannot have this modularity here. So if this is gray, you cannot have gray here. Or if this is blue, then that's the only blue on this line because it's only 4 rows, right? And blue, whatever is the modularity of the blue. So that is the property that these lines possess. Yeah, and now I think that is straightforward now applying here, right? See, whatever is the modularity of these two is going to be same modularity of these two. So let me just use some color for that. So whatever is the modularity of these two is going to be the same modularity of these two. And what is the sum of these two then? The modularity of sum of these two will be 2 mod 3 because this is 2 mod 3. So this is 2 mod 3. But together this is 3 mod 3 because 9. If you divide by 3 you get 0. So that's 3 mod 3. So that means this must be from 1 mod 3, right? Because this is 2 mod 3. Overall this is 3 mod 3. So this must be 3 minus 2, which is 1 mod 3. So let's use this color for 1 mod 3. So this is 1 mod 3 and this is from 147. But again, 7 cannot occur in 9 case. So this must be from 104. Now this and this has to be same, right? Because this is all modular line. So this and this must be repeated. So that is again 1 mod 3. And 1 mod 3 means that cannot be 2 or 5, right? That's 1/4. And 1/4 bits, now this cannot be from 1/4. This must be from 2 5. And 2 and 5, both is in the same group. So let's say this is pink color, right? 258 mode. Now clearly that cannot be 258 mode, right? Because this is on the modular line. This must be different from 258 mode. So this is 25. So yeah, so now this is 1/4 and 1/4 is from the same mode group. That cannot be 1/4, that from 25, and that is the same mode group as this. Now that's 25 mode group, that's 1/4 mode group, right? So what is this now? Because now this is 3 and this is total 1, so this has to be 1 mode group, right? Because yeah, this is 6, right? So let's simply say, right, this is any multiplication of 3 will do, and what is the nearest to the 18 number, right? So this will be 18 and this is what, just for 1 mod 3. I mean, it's not possible these to be 18, but it could be then 15 also, right? 15 and this could be 4, something like that. This is now yellow. Yellow, we know that 147, right? So I'm not going to place number now into this color. That will take unnecessary time. Oh, maybe I can do that later, but not now. So let's just color everything in these two. Now 12, right? 12 is 0 mod 3 and that is 1 mod 3. So to get from 1 to 3, you must add 2 into it, right? So that's 2. Now none of this is 2, right? 1 of 2 mod 3 is here, right? Oh, basically these both are yeah, see, this is yellow group, right? So this must be the other two group, right? And yeah, let's use the green color for 369 group. Oh, this one, right? This must be green, right? Because both the two are done here. So this is from 369 group. So here I will put 369 just to remind us that green is 369. These two we know now from both ends. See, and now what is happened? Look, so 2 yellow is here, 1 yellow is here. So all the 3 yellows are done here. And this is like again entropy line or any that kind of line. No, I think only entropy line, which is you can have 3 digits, right? You can group it into 3, right? So see, what is happening is that all the 3 yellow digits are gone here. In fact that must be one of 7, right? Because both 1 4 are 1 here. So that means none of this is going to be yellow, because only 3 yellows are possible, because there are only 3 yellow digits, 1 4 7. There are only 3 pink digits, 2 5. So every house, right, must have 3 of each color, and exactly 3 of each color. Now look, see what is happening now. That 10, right, that 10 is also going there, right? We don't know what are those numbers, but whatever that is, this must be 5, right? Because 15 minus 10 is 5, and 5 means 258. So that is now 258. Now 258, that must be now 147 or 9, right? So 9 minus 8, whichever is the nearest of here, we can take that, and that is 147. Yeah, even these two 9 9, right? 9 9 is coming here. So yeah, so 9 minus 9 is 0. So this must be from 0 group. So this is 369. And now that is also same, right? Of this. So this is 369, and that means that must be from 147, right? Because this is 9. This must be from 9. Oh, right. Now this cannot be yellow, right? So this cannot be 1 4. So that has to be 2 3. Oh, so both these are 2 3, right? Because 2 3 2 3, that has to be 2 3. So this is 2 3. 2 3 could be from different group, right? So we don't know this group, but I'm removing this coloring. So what is now? Maybe this digit. Maybe we can get this. Let's see, this is 6, right? And this is 9. So okay, before that we may have to discuss about what is the sum of these digits, right? Or the modularity of this box. So the modularity of this box is 0, right? If the entire sum of this box, if we do, is 45. Why? Because at the end of the day, this box will contain all the 1 to 9 digits. And what is the sum of 1 to 9 digits? 1 plus 2 plus 3 plus up to 9. That is coming out to be 45. That means this is going to be 45 modulo 3, which is 45 divided by 3 gives you 0 remainder. So this, the entire box is 0 modular, right? Or 3 modular. But now we know that that's 9 and that's 6, which are 3 modular. So we can ignore. So now this is 5 modular and this is 10 modular, which is 15 modular, right? So yeah, so 10 plus 5 is 15, right? This is 5 and this is 15. So if you take all together this, right, these are again all 0 modular, right? So what we need to add to 0 modular to get to 0 modular must be 0 modular. So this is 3 6. Let me just do that one. That 5, that 10, which is 15. So that we can ignore that. 15 means it's 3 modular, right? I mean 0 modular. So let's ignore that. And this is also 9 plus 6, 15. Yeah, right. So this has to be green. 3 6. Now these both cannot be green, right? See, this is green, both cannot be green, because then all 3 6 9 will be here and then 9 would be in the 9. So this has to be one yellow and one, because see, now this has to be green, right? Because this is modulo 3, and now from 9 modulo 3, if you minus 0 modulo 3, you again get 9 modulo 3, which is 3 modulo 3. So but this both cannot be green, which can give you 3 modulo 3. So the only other way to get 3 modulo 3 is using this arrangement, which is one is from 1 modulo 3 and the other is from 2 modulo. 1 modulo group and 2 modulo group. But that cannot be 9, right? So let's say that's 3 6 here. Anything else can we do here? Oh, see, that's yellow, right? So we know that cannot be yellow because yellow cannot repeat here. So that's pink. That means that has to be pink. In fact, that is not pink, right? That is yellow, because both pink is not possible. You will just get one, and if you add it into 3, you get 4 modulo 3, but that's not possible. So that's also yellow, right? Because of this. So this now both has to be either pink. So let's see. I mean, see, similarly here, right? We have one we have completed all the yellows here, right? Here we have completed all the purple or pink here. Okay, this must be now green, right? Because both other colors are here. This must be green or yellow. That's pink, right? So yeah, I don't know. So all these must be so this must be green or green or yellow, right? If it is green, that's yellow. So one of yellow must be here, right? Is what I think we can confirm. If that's green, that has to be yellow because 9 plus 1 7. Or if that's yellow, that will have to be green. So this has to be from green. But all possibly three. So except 2 at everything is possible. But this is definite from one green, one yellow. So this is also definite from one green, one yellow. Right, one green, yellow. But what we know now is that so this must be now from pink and green, right? Because all the yellows are done here, right? All the and 2 greens are done here. So this is the remaining one of pink and one of, which is obviously from here, right? Okay. That was obvious from here. Unnecessarily I have done all these things. Okay. But now what we can do? Yeah, that yellow is not helping here. This is yellow or pink. Because that's yellow, this is also good. No, let's do just one thing, right? Wherever there is possibility of both, right? Let's just color that. So let's not color across the box. Only in single box will color these kind of things. Double color, where we know that one is from each, one is from each. Across box, then it will be confusing, right? So I don't want to do that. Here we can do, right? Now what is happening? See, this is also across both, but this yeah, one of these is pink, that we know. So 2 pinks are done here. In fact, 2 pinks are done here in this line also. And that can't be pink. Oh, okay. That could also be pink, right? Yeah. See, what I was thinking is in this line we must have 3 pinks, right? 2 we are already got, right? Now none of these could be pink. I was thinking this must be pink, but then I realized no, this could also be. So one of these has to be pink. So now do we have to go to numbers? They both are possible, right? In 10, 3, 6 and 1, 4, 7, both are possible. Here 1, 4, 7, and here is also everything is possible except maybe 3, 6. Yeah, all other possibilities are there. 19 maybe. See, because both these are 1, 4, 7, right? So if we have 1 here, maximum this is 8, and that is then has to be 11, right? Yeah, which is not possible. So 1 is not possible here. So those are 4, 7. Yeah, and now we know that this must be 8, right? Because 4 plus 7 is 11, and so that has to be 8 to get the sum to the 19. So that's not it, and that's not it. Both these are 2, 5. 8 is not here. Does that help it? No. Obviously 8 was anyway never there because this is 9, right? Even 7 is not there. So if that's 2, that sums to 13. 4, 9 is possible, right? Or even 6, 7 is possible. Nothing. I can't think of where does that 8 help. Maybe it will come to coloring this 1 4 and 2 5 individually, something like that later. Oh, what are these possibilities? That can't be 1, right? Because then that will be 11. So that's 4 7, and accordingly this must be, if that's 7, that's 5, and 4, that's 5. Some limitation there. So it is something like in each row, column, and box we have to figure out which one could be which one. So something like, see, yellow is not here, right? So that means yellow is not here. We have definitely 2 yellow here. So one of these is going to be yellow. So 2 yellow in these boxes. So some kind of those kind of reductions I'm outside. And then using the symmetry, maybe we can take those reductions into other. See, something like, right, we know that all the pinks are done here. And all the yellows are done here. But we are not getting it into this box. So none of this is pink. Oh, you must have 2 pinks here, right? See, because there is only 1 pink here, which is in terms of 2. You do not have any pink here, so there must be 2 pinks here, and all the pinks are done in this box. So everything else is so that is not pink, right? Oh, okay. I think I got this. Yeah, right. So 1 pink is here, and we know that there is no pink here, right? Because all the pinks are done. So no pink here, 1 pink here, but we must have 3 pinks here, right? So that means these 3 digits must have 2 pinks at least. Not at least, exactly 2 pinks here. Now 2 pinks, and this is 1 pink, right? One of these must be. So those are 3 pinks. That means these cannot be pink, but then these cannot be yellow also, because this is on 9. So this has to be green. And if this is green, we know that this cannot be green. This has to be pink. This has to be pink. That cannot be green, right? Because we know one of these was pink or green. So that's green, and that's green. Now green means we know now this digit. This must be 3. This must be 2. And my pencil mark is also, I'm going to off this for now. Everything is for now because I don't know the future. Yeah, so that kind of thing is there. Maybe let's check that. Yeah, we know that there is no yellow here. Oh, but there are 2 yellows here. Oh, there was only 1 pink here. No yellow here. There are 2 yellows here. That means there is exactly 1 yellow here. Right, didn't I? There are 2 yellows here. Oh, okay. Maybe here. Oh, so now at least we can have this, right? We can have this pink and yellow, right? Because green is here. So now we know that there are now 2 of everything, right? We got here in this thing. That is now 1 of everything. In this box we got 2 green. In this column we got 2 green. Okay, that's 6 or 9 at least. So that means that has to be 1 or 4, right? Okay. If that's yellow, that's 7. If that's yellow, that's 7. And we know that none of this is yellow because all the yellows are done. 2 greens are also done. But that could be green, right? We must have 2 greens here, right? So these are 2 greens and 1 pink. No, that's not working. Oh, we haven't got this, right? At least in others. we were able to figure out the both the types. Here we are not able to do that. 9, that cannot be 9, right? So that has to be 3 or 6. And that's 2, 5, it cannot be 8, so that's 2, 5. 9 is now one of these. Can that be 9? 9 plus 6, yeah, that's fine. That's fine. 9 could be here. Anything could be here. I don't know. See, 3 different E's, right? And 3 different types in 50. Okay, what is that maybe? That can't be 7, right? So that's 1, 4. You could have 6, 1, 2. Or could have 3, 5. Is 5 possible? Yeah, 5, 1, 3. Come on. But only 5, 4 you cannot have, 6, 4 you cannot have, 5, 6 you cannot have. So one of 3, 5, 6, one of 1, 2, 3. This kind of become also entropy. 4 plus 6 plus 3. I don't know. I can't think anything about that. 3, 6, 4, 7. Come on, man. Think a little bit harder. We get something like this, right? Something like that we should get. Somewhere it is there, which I am not able to see. 2 of yellows are coming, right? So 2 of pinks are coming, right? Both yellows are gone here. That could be yellow, right? If we can figure out from here, right? If we get these clears, right, then this will be get clear. But that's definitely not pink, right? Only we got one pink here. So one of the pink is here, right? So 2 pinks will be done. Yeah, but there could be 2 pinks here, right? This cannot be pink, and then you could have 2 pinks here. That's not pink. Okay, think. Or maybe look. So this needs 2 pink, right? This needs 2 pink. Can it have green? Because then there won't be no green here. Oh, it can't have green, right? See, if there is green here, all the greens are gone, and you can't have any green here. But there is only one green, so maximum you will get 2 greens here. So you do not have green here. So the third green is here, but there is maximum only one green, and there is maximum one green. So this must be green. So in this box, this has to be green. Alright, because you cannot have any. If you have one green here, alright, this green is not possible. This must be green, but still you will have only 2 greens, right? So there is no green here, one green is here, and then you still have only maximum 2 greens, so this has to be green. So now you got 2 green. This is green and yellow, right? So we can put that green and yellow. So 2 yellows are done here. So now we know that this is 2 pink and 1 yellow. If this is 2 pink, 1 yellow, this is 1 yellow, 1 green. So now we got 3 greens, 2 yellows. Two greens, 1 yellow we got here. Come on. So in this row we got, between these, right, we got 2 greens, 2 yellows. We don't know that, right? So you must have some pink here, right? At least one pink. So there is max one pink. No, 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 no. Maybe something like 3, 6, no. 1, 4, 4, 7. That green, right? Will that green help somewhere? We got two greens here, right? If that's green, if that's green, that's yellow, that's pink. That would be green. That would be green. That seems fine. It's not like that. It's not like that. There are two greens here, so maximum one green here. Oh, is it correct? See, in this column, we do not have any green, right? We know two of greens are there. So maximum there is one green. There must be at least two greens here. No, that is not helping. What if there is no green here? Then all these will be green, right? One of these may be. No, 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 not this way, not this way. One of these is yellow, we know that, right? Because none of these could be yellow. And we still need one yellow. Either that cell or that cell. If that's yellow, that's pink. We need two yellows here, right? In this box. Ah, come on. Come on, come on, come on, come on, come on. I'm not seeing things. Maybe because I'm talking too much. Ah, yellow here. There is exactly one yellow here. Two yellows. 3. One of these has to be green, right? Right, one of the, because that can't be green. One of these has to be green. And exactly one of these has to be green. So those are two greens. That can't be green. No. I'm thinking. Maybe I'll edit this part when I see something. Uh, some simple thing should be there. Hmm. Two. Oh, that two is looking at this. Yeah, that's a simple Sudoku. That's two. So now two must be here, right? Where could that go? That could go only here. Oh, shit. See, simple Sudoku helps, and that's definitely not green. That's pink, and that's not pink. That's green. That can't be two. That's five. That's two. That two should do something here, right? That should something of seven. Oh, both is possible. Damn. Okay. Oh, that five must give now one here, and that's four. That one is not doing anything. See, all the three greens are done here, right? So no more green here. One of these has to be green. There is only one yellow here, right? Hmm. Two. So two is not here. Two is not here. Where is the only other two? Alright, in this box, where is the only other two? That has to be two. So that's not what am I doing? That's not yellow. That has to be pink. And now this cannot be pink. This has to be yellow. Two. There has to be two here. So one of these has to be two. That could be two, but we are not so sure. Two, right? Yeah, both these to be two. Five is not. Wait. I think. Now, yeah, let's just continue this, right? If we can get two. No. I don't think. Yeah, so we have to do Sudoku intermediate in between. So now what do we got? We got here, we got something here. 2A. All the greens are done, right? That would be, yeah, that was already there, right? Because we know that there is no green here. One, two. We got this. Oh, this has to be pink, right? See, because maximum one pink is here, right? 2, 5. There has to be some 8 here, right? But maximum one pink would be here. And in fact, one pink has to be here because if there is maximum one pink here, in this row, if you see, there are maximum two pinks. So this has to be pink to get the third pink. So that's pink, and that's not pink. That has to be yellow. One of pink is here, and the other must be green, right? So in this pink, where is third yellow? Third yellow cannot be here because all the three yellows are there. That has to be yellow. And if that's yellow means that has to be green. That has to be 7, right? Sorry. This is not 7, that 3, 6, 9. This is pink and green, right? Yeah, so this needs 2 green and 1 pink. This is 1 pink, 1 green, right? Okay, so this needs 1 pink and 1 green, right? That means this is definitely green. All the greens are done. All these are yellow and pinks. No. Hmm. Any line we have missed? No. Okay. So slowly we are doing some progress, or at least I am doing some progress. You guys may have finished by now. Uh, what else now? So 2 and 5 help us, right? 8, 4, 7, 4, 7. Can these be both same 4, 7 or different 4, 7? Oh, 7 is looking at that, so that's 4. That's 7. That 7 is doing something, that 4 is not doing anything. Okay. That's so 1. Oh, so 7 is out of here, right? So 1 of 1 or 4 is here. Okay, let's come back to that math if we do not have anything else to do. Oh, so we know this, right? This is green and pink. Two greens are definitely there. One of this is green. So I am thinking, is this green possible or not, or this green? If we figure out that one green has to be here, then that won't be green, right? Something like that I'm trying to do. So two greens are already there. In this box, what is the situation of green? One green is there. Now there could be no green here, right? Okay. Maximum one green is there, right? That's 1, that's 2. Nah, no, green is that's not the way of it. Oh, that's not green, right? That's we know that that's pink. Don't come to the same conclusion again. Um, then, uh, no, no. Two yellow. Oh, one of the yellow must be here, right? Because only two yellows are there. Why one yellow must definitely be there. That's two yellows. Come on. Third yellow could be here or here. Oh, look, look. None of this is yellow. Oh, that's pink, right? And that can't be yellow. So this has to be green, isn't it? So I should have looked at the line also. See, all the yellows are done here. Okay, in this box now, all the yellows are done, and that is pink. So this cannot be yellow or pink. This is green. That means none of that's green, and that means none of that's yellow. Okay, uh, that is not true, right? And so that has to be two, right? Which has to be now pink, and that's not pink. That's green now. That's 147. 7 is not there, so that's 1 4. That's 369. I don't want to do this math yet. That's 147. 369, everything is possible. Oh, now, but these two are now from between yellow and pink, right? So all the yellows are done, isn't it? All the yellows are done. Yes, I'm. One of the green is here. Oh, only one of the green is here, so that has to be green to complete all the green photos in this. One of these is, so that's green or pink, right? Yeah, that has to be pink, right? Because one of these is green. Yeah, one of pink is here, right? One of the pink is here, and one of the pink is here. But look, that means in this column we got only two pinks. Must have third pink. That has to be here. So that's not pink, that's yellow. Now this pink will be done by this only. 5847. That will be still anything. That's 369. One of okay. 4364. 36. That's 369. Oh, it's not bounded. Now, all the threes are done, right? One, two greens are definitely there. Two greens are here. Oh, okay, three greens are here, right? So no more green here. Whatever the one green here is between these. Wait, three yellows are done here, right? That's the simple way to look at it. None of that's yellow. And now if that's green, that cannot be done here. In fact, if that's green, oh god, now I forget what was this. Oh yeah, you must have third yellow right here. So that is yellow. That's not green, that's yellow. And now what is this now? In fact, you got three pink here, so that's not pink, that's green. That's not green, that's pink. And surely we are proceeding much faster now. That's three green. So how are you going to come back to numbers now? Maybe some Sudoku? We just do that. Maybe we get something. Nope, nothing. We're still there. 1474. That's 17, right? Let's just put that. 369, 369. All these green are done. No. We need two yellows in this box, right? And two pinks and one green. That's yellow green, right? So all the pinks are done here, right? Yeah, and all the yellows are done. That has to be green. That green must be now 6 or 9, right? 9. So this is now from one yellow and one. Yeah, right. From this box also you can see one yellow and all the greens are done, right? Yeah, we should be able to finish off greens maybe. None of that's green, right? So one of the green must be here, which has to be here, right? See, one green must be here, right? It can't be here because all the greens are done. Can't be here because all the greens are done here. So this has to be green. So there is one green here, right? Yeah, that's obvious. That's not giving me any conclusion. No. Something else you have to look at. All the lines coloring is done, right? At least, yeah, all the line coloring are done. So now it's just scanning. So yellow. One of the yellow is here. One of the yellow is here. Maybe it's about pink now because pink I'm seeing very less. Oh, two pinks have to be here. Right? Could be anywhere. Two pinks. Oh, two has to be here, right? Yes, that's also no. And that's 5-8. If that's 5-8, that's 1-4. Oh, that 2 directly gives 7 here, right? So that's 1-4. That's 1-4. 1-4, 1-4. We need 7 somewhere. In this. We'll come to that later. 1-4. One of these is 1-4. None of this is 1-4, right? Oh, okay. So that helps. See, 7, right? Whichever is the yellow must be 1 or 4, but that cannot be 1 or 4. So that's not yellow. That's pink. and that means that's not pink, that's yellow. Right, so we got now two yellows here. This must be from yellow and pink. That's okay. And this must be from pink and yellow. Oh, so all these are from pink and yellow. Now, so 7 is one of these, right? In fact, that has to be 7, right? Just by SUDOKU, and that's 1/4. Now 7 cannot be there. So 7 has to be one of these, right? That means, and 1/4. So yeah, 1/4 7. That cannot be yellow, and that cannot be green. That has to be pink. That's green and pink, right? One of the green has to be here, right? We have decided that for some reason. So both the greens are, that has to be pink, which has to be now 5 or 8. One of the 1/4 is here. Okay. 6 9, that is 6 9. 3 is one of this now. So that's not 3, and if that's not 3, do we have some total here? Because there is not 3. There's other 6. 6 means this must be now 9, 5 4 4 5. Or if that's 9, this must be 6, which is 1/4. Or okay, this could be then 1 5 or 4. So everything is possible. Okay. 8 is one of these, right? Right, so that has to be 5 now, right? The other way to see is that where is 5 in this row? It has to be there. So that's it. 8 is not here, 8 is not here. It has to be somewhere here, right? And 5 has to be somewhere here. Okay. So this is 5 7, right? Yeah. And this is now 8 1 4. Sorry, that is 8 1 4. 8 1 4, but 1 4 1 4 is here, right? So that has to be 8, and that has to be 1. 8 we know that it is pink, and 1 4 is we know is yellow. 5 7 we don't know. That should come to 7, which is still both possible. Come on. 1 4 1 4 1 4 7 done. 3 6 9. This could be everything, right? 3 6 9. That's green or yellow, right? Let's just mention that. In fact, one has to be there. Okay, so 7 has to be somewhere here, right? All the greens are done, right? So this is 2 pinks we still need. Come on. These two, right? Yellow or pink. Come on. Which could be possible, right? Even here also, pink is possible or yellow is possible. Green, maybe if we can figure out where the green is. One of these is green, right? And that I have already concluded. None of these green, that's fine. No. Must be some kind of SUDOKU now. Are we not done with 2 yet? Oh, 2 has to be now one of this, right? So that's 2 or 8, right? Because we definitely know that that is pink and that's not 5. No, 2 we were looking at it because 2 helped us earlier. 2 is one of these. 5. 5 is one of these two. Okay. Mm, 5 is one of these two. 7. 7 is one of these two. Oh, there has to be 2 yellows here, right? That can't be yellow. So we need 2 yellows here, right? None of this is yellow. We need 2 yellow here. But all the yellows are done here. So both these has to be yellow. Wow. All the yellows are, in fact, all the yellows are done here, right? So that has to be now pink. That has to be now yellow. And we know now this digit set. That has to be 5. That has to be now 7. That's not 7 now. That has to be 7. And that's the remaining of yellow, which is 1 4. 1 4 2 7. 1 4 1 7 3 6 9. 9 has to be now found here, right? Because that's 3 6. So while doing 2 5 8, we got all this. Maybe 5 will still help us here. 5 is one of this, right? 5 is not, so that is 2 5 here. And 2 5 means that was actually given here. So that is 2 5. We still need these two, right? What are these two? Green and pink. So maybe yellow, right? Looking at 7, we got something. So 7 is still one of these. 7. That's 1 4, right? Should I put that? Let's just put that. 7. Oh, that's not 7, that's 1. That's not 1, 7. That must be 4. In fact, that must be 4. And that must be 6. 4 means that's not 7. And if that's 7, that has to be 5. So that's 2. That's 5. That's 2 means that's 8. That 8 means that's 2 and that's pink. That's not green, that's pink. That pink means that's not pink, that has to be green. We know that this must be from 3 9. That's pink, right? Which has to be 8. That's green. So now we are getting all the colors. Which has to be now 3 6. Because 9 is somehow one of these. 3 9 3 9 6. Okay. 7 7. That has to be 7. We just click 7. We'll find out that that has to be 7, which is yellow. So that has to be 5 with pencil mark. That's pink. That has to be pink, right? Because both yellow and green are here. So combining this thing, all yellow and green are one. So that has to be pink and that has to be 8. With that, now we know that that has to be 8, which is now pink, and that can't be pink, that is green. Oh, so this has to be now 3 9 because of 6 here, and that's 6, and that 6 means that has to be now 3 9. This has to be, yeah, this has to be green now, right? All the yellows are done. That's green. Green. Wait. Why did I select this? Okay, I don't know. But that green means that's not one, right? This has to be one, which is yellow. Green, that has to be green, and because of this 6. 6 is one of this. All the colors are done, right? 1, 2, 3. Yeah, that can't be. That is then green. The remaining is pink here, right? And that means that is what's wrong? Wait, something is wrong. That's green. That means that's not green, that's yellow. That has to be pink, and that has to be yellow. Yeah, now things are fine. So now that's 7. That's not 7. That's 1, 4. Now what? Because we got all the coloring, right? That's 2. Means this must be 13. The only possibility is 9, 4, right? Yeah. So 9, 4. That's not 9. That's 1. So that means that 5 plus 1, 8. 6. 6 plus 3, 9. Oh, is that 5 or 1 going? Yeah, that 1 gives 4 here. That 4 now, 4 plus 2, 6. So that has to be now 3. That's 6. That 3 gives 9 here. That gives 3 here. That gives 9 here. That's 3, 6. Oh, that can't be 6 now, right? So that has to be 6. That has to be 3. That's the only remaining. That's 9. That's 6. 3, 6. That has to be 9. That's not 9. That has to be 9. 3, 6, 9, 6, 9. Okay, this is 6 or 9, right? Out of which 9 is out of question. So that has to be 3. 6. That has to be 3. That has to be 9. 9 means that has to be now 1. Because of 10, that has to be 4. That's 1. 6. That has to be 3. That must be 6 now. Let's just finish all the greens if we can. No, we cannot. What is remaining? Because I don't see any green in any of the caves or something like that. Wow. Oh, 9. That's not 9, right? And that's not 9. So that's 3. That's 9. That 9 gives 3 here. That 3 gives 6 here. That 6 gives 9 here. That 9 gives 6 here. And what else can we do now? 1, 4, 1, 4 still. Oh, this 5 is 5 is still. That's surprising. Oh, 8 is looking at that. Yeah, that's what I thought. That's 5. That's 8. That 5 gives 4 here. That 4 will give 1 here. That 1 will give 4 here. That 4 will give 1 here. There's the remaining one which is cannot be 5, right? And 5 has to be here. So that has to be now 8. Oh, remaining. Something is remaining. I got scared because I thought something is wrong. That's 4. And I hope now our puzzle is complete and it's correct. And it is correct. 65 minutes it has taken. I think this was kind of half an hour. Yeah, maybe because I have explained all the modular. But yeah, I just took some time here, somewhere in between. I really took a lot of time to figure out some deductions here. Something could be green or could not be green. Oh, and then, yeah, somewhere Sudoku was also there in between. I should have thought of that. I was thinking only in terms of the coloring. So, can we get all the coloring? But it wasn't possible without getting some of these digits back. Yeah, okay, anyway, so that's the puzzle, and I hope you guys have done this much better than me. But anyway, if you are till here, then thank you very much. And try to like this, share this, or comment this if you have anything better way to solve this. So anyway, thank you very much, and goodbye.